used to specify the UML meta model. Okay, so it is used in UML models in conjunction usually with the class diagrams. Okay, so it's formal, meaning that the syntax is very precise, like a programming language. Easy to use, meaning that it's not too complicated. So with that, it's unambiguous and no side effects, meaning that it actually just describes the behavior. It does not cause the class to behave in a certain way. For instance, it does not change the variable, the value of the parameters. Okay, so OCL is not supposed to have side effects. It's just merely a description. It will not affect, for instance, the value of, it will not change the value of parameters. Okay, so it's just a description with no side effects. Okay, and they are declarative. Okay, so they specify what must be true. So the constraints here, the statements are always a Boolean expression. Okay, it's always a Boolean expression, and they specify that this particular Boolean expression must be true in certain situations. Okay, so it's a Boolean expression, and it does not change the state of the system. I explained that to you. All right. Okay, ready to go to the syntax itself. So I'm going to show you. Okay, so there are three classes of constraints. The first is an invariant. Okay, so an invariant means that for all instances of this particular class, this particular constraint must be true. Okay, invariant. Right. So the keyword here is INV. Okay, INV for invariant. All right, and so when you see INV, it means that for all instances of this particular class, this particular Boolean expression, okay, in the constraint must be true. Okay, the second situation is a precondition, and here the context, right, instead of applying it to all instances of the class, the context is always an operation. Okay, the context here is always an operation, and what this says is that this constraint must always be true before you are allowed to do this operation. So before you're allowed to call a particular method, you have to check that the condition is true. So this constitutes a precondition. Right? So the keyword here is the word pre, P-R-E. Okay, you will see it later on. Okay, and finally, the third situation is a post condition. Okay, this means that after executing that particular method, this particular expression must be true. Okay, so of course the keyword here is post, P-O-S-T. All right. Okay, so you have the keyword INV for this situation, for preconditions, P-R-E, and for post condition, P-O-S-T. Okay, so these are the keywords that you need to pick up along the way. All right, so let's take a look at an actual example. Okay, here we go. All right, so here are the keywords in bold. The word context is important, so you always start off with the context. So in the class invariant situation, the context is the class. Okay, but for pre and post conditions, the context would be the operation itself, right? As I said. Okay, so I will show you the syntax for that. Okay, so here is the syntax for class invariant. So for this situation, okay, if you look at this particular class, the number of current courses that a student can take must be less than or equal to 10. Okay, so use the keywords context and invariant to specify the class invariant. Okay, so this is applicable to all instances of students. Okay, now when, am I blocking you? If I do this? Okay, so, whoops. Okay, so now we want to look at pre and post conditions. If you look here, oops, where's the laser? It's gone somewhere. Okay, so if you look at the bottom of the slide, you will see that for the method getAge, okay, there is a precondition, okay, and a post condition. So before you can call getAge,